Hi, my name is Luis, and this is the image colorization using convolutional neural networks project. So a bit of background first, I guess, in an introduction, is image colorization is mainly done on old black and white media, mostly for artistic or aesthetic purposes. Um, However, this can be fairly labor-intensive and tedious to do by hand, and neural networks are actually a great way to speed this up and do it automatically. This is especially worthwhile for footage where it's 24 frames a second in black and white that you want to colorize. And automating it using neural networks is a great way to make this task easier and more widely available. Yeah, so our inspiration for this project was RDAO's webpage, where he has a bunch of pictures that he posted and colorized using a neural network. So these are a few of his examples. So you can see on the left is the black and white picture he fed into the neural network. On the right we have the ground truth, and in the middle is his colorizations. So you can see they're not perfect. You can see like patchiness of uncolorized, still black and white pictures, but they're actually pretty good. The leopard actually looks like the leopard, and the grass is actually picked up to be green in the trees. Yeah. Another of our inspirations was a paper done by Stanford, which pretty much does the same thing, but the key distinction was RDAL uses regression to determine the values of the pixels. So you can see a bunch of the colors are actually washed out, so it doesn't pick up the green. It kind of averages the colors, and they don't really pop out. What the Stanford paper does is they actually define this as a classification problem. So it forces the classifier to choose a color, so they actually get brighter tones. Yeah. So combining these two features, we went ahead and picked our data set, which is MIR Flickr 25,000 images, about 3 gigabytes. There are a lot of varied pictures, and they're also picked from the more. Flickr has an interestingness rating, and these are actually the more interesting ones. So that makes for a very challenging set, I guess, to train on the neural network. It'll get a lot of information from that. Yeah. So what we did is we actually had the pipeline where we decided to do the image processing in MATLAB. And one of the things we noticed reading the papers was a lot of the papers don't use RGB for a few different reasons, but the main ones being RGB has 3 color channels, and they'd rather just train 2. A lot of the HSV space, lab space only have 2 color channels, so of course it's easier to train 2 channels as opposed to 3. Yeah, and there were other few reasons, but that one's probably the most compelling one. Yeah, so in MATLAB, basically what we did is we transform our picture, which is RGB, so 3 color channels, and we instead take it to lab, which is L for lightness, which is basically the intensity, A and B, which is basically the 2 color channels. Yeah, and that's what we do. We also based our design of the neural network on, so yeah, neural network, there we go. VGG16, which is an image classification CNN. So it originally was made to, I think there's a version of 10 classes and another one of 100 classes, but it basically just takes an image and spits out probabilities for 1 to 100 classes and takes the highest one, and that's what you get. So we actually took it and modified it to actually suit our needs. So here's a picture of what VGG is like. And the key contribution from Dao's paper was he adds these other links to he takes the outputs of the VGG16 and then further feeds them into a parallel branch. And at the end of that, you just get the output color channels. So we modified this neural network. We did this in Keras, by the way, which is actually pretty easy to build your architecture layer-wise. So it's very good at linking and building layers. Yeah, and the key point was the VGG16 takes in, because it's made to work with RGB pictures, it takes 3 by 224 by 224 image. So we modified it. We feed it basically the black and white intensity channel concatenated 2 times. So it's a 3. It's the single channel 3 times basically. Yeah, and then we train that, and at the end we get the output. We get the 2 layers, so 2 by 224 by 224. Yeah, so so in MATLAB, what we basically had to do was crop the picture, then scale the picture, then convert from RGB to lab space. And then what they do is, because it's a classification problem, instead of actually having the intensity value of, let's say, a single array of a 2x4 by 2x4, the neural network outputs, let's say we had the 50 classes, it would need the output layer would be 224 by 224 by 50 for a single color channel. So we needed to discretize the pixel values of the 256 values, bring them down to a range of 1 to 50, and then do the one-hot representation across that dimension. So we actually went from 224 times 2, and then we inserted the 50 bins we needed to classify, to obtain the right dimensions to classify the image. Yeah, and basically we had one MATLAB script that did this and took the RGB into this format that we fed into the neural network, and then we had another one that undid the process and allowed us to take out the output of the neural network and reconstruct the image. So that's it for our pipeline, basically. Let's see. Yeah, so this is a bit of the, I won't be covering this, but it's, anything else? Yep, and that's it pretty much. Thank you.